Welcome back to Around the World in 80 Telescope, a live 24-hour webcast that is part of the 100 Hours of Astronomy project for the International Year of Astronomy. You're joining us at the European Southern Observatory, headquarters near Munich, in Germany, as we visit some of the most advanced telescopes, both on and off the planet. We're now going to Nobeyama radio astronomy in Japan. Before we join them live, let's find out about them in this video.
National Astronomical Observatory of Japan, Nobeyama. Located 1,300 meters above sea level, a small village in Nobeyama is the home for the Nobeyama Radio Observatory and the Nobeyama Solar Radio Observatory. Researchers and students from around the world visit Nobeyama for high-quality astronomical research and cutting-edge instrumental development. The 45-meter telescope is one of the world's largest radio telescopes that observes in the so-called millimeter wavelengths. Using every bit of the giant 45-meter dish, astronomers collect extremely weak signals from nearby space where stars are just beginning to form to distant terrestrial objects. Advanced machinery and a sophisticated software control system makes this all possible. Because millimeter wavelengths penetrate through dust, what appear as dark spots in optical images become visible using the 45-meter telescope, allowing Nobeyama astronomers to explore the dark universe. The ASTID telescope is the state-of-the-art 10-meter telescope that observes primarily in submillimeter wavelengths. ASTID is located in the Atacama Desert in northern Chile, 4,800 meters above sea level. Here, the exceptionally dry air provides the best observing conditions. Astronomers operate the telescope from a remote site in Chile or from Japan by sending commands through the internet. ASTID has been producing astonishing images of the center of our own Milky Way galaxy, nearby star-forming regions, and distant galaxies. The Nobeyama Radio Heliograph is a radio telescope dedicated to observing the active sun. By electronically connecting 84 parabolic antennas, each with an 80-centimeter diameter, the telescope becomes as powerful as a 500-meter diameter telescope. The radio heliograph generates a maximum of 20 images every second, regardless of the weather condition, allowing astronomers to monitor the activity of the sun continuously all year round. The Nobeyama Radio Polarimeter observes the sun with 8 antennas and 7 different frequencies in the microwave wavelengths. These specially designed telescopes allow astronomers to understand the active sun, and it plays an important role in investigating the long-term variations of the sun. Nobeyama astronomers work day and night, all year round, to explore from nearby celestial objects such as our own sun, all the way to distant galaxies that are millions of light years away.
太陽フレアは太陽表面で観測される活動現象の中でも特に大きくダイナミックで目を引くものです。太陽フレアに伴って2筋の明るい領域が広がっているのをよく観測されます。これを電波で見てみるとどうなるのでしょうか。延山電波ヘリオグラフで観測された電波像はその中のごく一部でのみ電波放射が出ていることを示しています。これは強いエネルギー解放がその場所でのみ強く起きていることを示しているのです。
The Orion Nebula, one of the brightest nebulae in the sky, is a region in space where a dazzling variety of stars are born. Nobeyama astronomers observed the entire Orion Nebula using the 45-meter telescope and discovered ample amounts of molecular gas all over the region. They further found that the brightest part of the Orion Nebula, called Orion KL, harbors a number of complex molecules,